Hi all, welcome to Soumya's Tech Talks. Today we will start lectures on the C programming tutorials. Before going to C programming, let's first understand how a software program runs. So we will briefly discuss about that. As we know, the computers can only understand the machine code, right? Which is in binary form zeros and ones. But we normally write the software source code in textual form in English using, if you use any programming language like C, C++, Python, you write in the textual form. So what happens here, your text text code should be converted into the machine code which your platform understand. So for example, you have written source code in C, C++ or Java. So it will be build through a build system. So the build system actually converts your code into the machine code, which is in zeros and ones, where the target platform can understand it. So in, if you want to write any software application, there will be three stages. The first thing is we have to write a source code for the application. So using any programming language like C, C++, Python, and using a development IDE, we normally write the source code. Like in olden days, people used to write the command line, like basic command line they used to write. But in modern days, so there are a lot of IDEs called integrated development environment like Visual Studio Code, Eclipse, NetBeans, PyCharm. There are a lot of tools. So where you can easily run the write the source code, and you also build, and it will show the errors, you have to fix it. So it is very easy to develop a applications using the IDEs. So the next, the whatever code you have written, it should be built and should be converted to a executable which can be run in a target machine. In general, the platform on which you are developing the software, like you run the software, like you are developing a software on the Windows machine or Linux machine, you will build it and make a executable, but the executable may not run on the same machine. It may be different platform. Like you write a mobile application on Windows, so once you make a executable, it will be run on the mobile. So the target platform is always different from the platform on which you are developing. So once you have written the source code and build it and generate a executable, so the next step is deployment. Deployment is nothing but you install that executable which you have developed here in the target platform. For example, you have written a mobile application. So the deployment means you have installed that mobile application in your mobile. So that is called deployment. So the third step is, which is runtime. Like runtime is, so when you open that application software on the target platform and run it, when you are using it, that is called the runtime. Okay. So here, if you see, so here we briefly discuss about what is the process involved from the development of software till you make a executable. So here there are a lot of things you may not understand, but don't worry, we will discuss in the later lectures clearly. Today we will only go briefly into the each one. Okay. So first thing is, we will write a software program which contains a single file, or you can have a multiple files you will write. So next, in the build process, once your program is ready, so you will build it. So in the build process, first processor preprocessor will comes into the picture. So it will in, let's say in your software code, there will be a lot of files, and in each software code may externally link to another files. So you may be using any header files, external files where like system libraries, something. So that the preprocessor will resolve all those dependencies, and also compile time variables, like we will discuss it later. Like in C we have a macros, like we define a compile time macros, and there we will write in C++, we will write lot of directives. So all will be handled by the processor. So we will discuss these topics earlier, later. Third one is compiler. Here is the actual work will be done. So first the compiler will check the syntax, semantics errors, whether your program is correct, you have written in the proper rules and regulations of the uh, programming language or not. And it will translate the complete all your source code in different files into a assembly language or any intermediate code. So the compiler's output is different for each programming language. So each of your source code file will be converted to a intermediate code. So the next in this process comes assembler. So the assembler, what it will do, it will convert your assembly language instructions which is generated by compiler into the machine code. So then linker will come. Linker's job is, as you have multiple source files, if you have each this your compiler and assembler compiled it and make object files or any intermediate files, the linker is will combine all these files together. And also if you are referring to any external libraries or external APIs, that also it will link to your source code. And finally the linker will generate the executable which uh, you will run on the target platform. So here the compiler assembler mostly uh, depends on what platform the code will be running. So your build system, the compiler and assembler in the build system will generate based on what platform. So what is your target platform? Either it can be a mobile or it can be a small embedded system. So according to your target platform, it will generate the executable machine code, which is a single executable. So as we discussed, right, the programming language, how it compiles and builds. So based on that, we have different variants of programming language. The first one is compiled. So here in compiled programming language, your entire source code will be converted into the machine code at one shot. Like once you build it, your executable will be generated for the target platform. For example, C, C++. So it is a compiled languages. Okay. So your target platform on which your executable will run may be different from the machine on your on which you are developing the software. Okay. And your build system will optimize your code, like it will reduce the instructions, duplicate instructions, and optimize according to your target platform. Okay, these type of compiled languages are mostly suitable for low-end embedded systems. Like if you see any small Bluetooth speakers, microphones, any small sensors, those kind of systems. So these compiled languages like C, C++ are used for these kind of embedded systems. So next, there are interpreted languages. So here your source code will not be compiled. So like if you see for example Python, so your source code, when you run the Python code, it won't generate any executable. Like your Python will be executed line by line. Let's say you are running a small Python script. Okay, line by line it will execute, and runtime only it will convert the interpreter. Inside the Python interpreter will convert your instructions into the machine code while you are running, not prior to execution. Okay, so there will be no compilation step. Okay, while executing only you do compilation and everything, but it is slower because while running you have to run the software instructions. At the same time, the programming language instructions in the textual form also same time converting into the machine code, and it also running the same instruction. So it is slower than the compiled. So it is not suitable for the low end embedded systems. So it is only suitable for Windows, Mac, Linux computer which have more memory and CPU. So these are the interpreted languages. So third one is just in time JIT languages. Like, so what it will do, first your source code will be converted into byte code. For example, Java, C, sometimes Python also. So your code will be not converted into machine code, but it will be converted into some intermediate form, byte code. Okay. So in runtime what happens, there will be a virtual machine. Like in Java there is a JVM, in Python it has its own interpreter. That interpreter, when you run on the target platform, uh, it will convert into the machine code instructions. It is also suitable for mobile phone, tablets. Also, it is suitable, and Windows. But this is also not suitable for the low-end embedded systems. So that's it. For example, right now we are only focusing on C, right? C programming language. So normally C programming language is a compiled language. Like when you write any application in C programming language, so it will be after your build, it will generate the executable, which is targeted to the target platform. Yeah. In the next lecture, we will discuss on installing necessary tools for C programming development. See you all in the next lecture. If you like our videos, share with your friends, and also don't forget to subscribe our channel for more videos. Thank you.